Hey mathematicians, today we're going to start with exponent rules, multiplying, dividing, and raising them to a power. Just a little vocabulary. The exponent is the number of times you multiply the base by itself, and the base is the variable, constant, or expression that's raised to an exponent. Okay, a quick note. There is no addition or subtraction rule for exponents. X to the second plus x to the third is not x to the fifth. These aren't like terms. You don't multiply, you can't add them together. So if you have 2x to the third and 3x to the third, you could add those together to get 5x to the third. Nothing happens to the exponent or the base. You just have 2 of something, add 3 of something, you have 5 of something. So multiplication rule. So when multiplying exponents, you add the powers. So since we know that 2 times 2 to the third, and we know that's 3 2's multiplied together, if we expand it out, this is called expanded form, we have 2 to the fourth power. So down here we know x to the second is 2x's, x to the fourth is 4x's, so now we know we have x to the sixth. Okay, since mathematicians are too lazy to do this every time, they just say it's x to the 2 plus 4, which is x to the sixth. Now when we're doing something like this, we have coefficients, we want to group those together first. Because multiplication is commutative, we can move these around. So now we know that 3 times 4 is 12. And we have y to the third times y to the third, so that's y to the 3 plus 3. So we have 12y to the sixth. Division. So since when we multiply, we're just expanding them out, the more multiplication, that's why we add things. Division's a little different. So if I have 3 to the fourth, means I have 4 3's in the numerator. Divided by 3 to the second, so it means I have 2 3's in the denominator. 3 divided by 3 is 1. This 3 divided by this 3 is 1. So we cancel these things out, all we're left with is 2 3's. So 3 times 3 is 3 to the second. Again, mathematicians are too lazy to do all this. All we're going to do is subtract the powers. We're going to call it 3 to the 4 minus 2. That's where 3 to the second comes from. Same thing with t. It doesn't matter if it's a variable or a number. T to the fifth divided by t to the second. I'm not going to expand this out because we're lazy. 5 minus 2 is 3. Just like when we multiplied, we noticed that with the coefficients, the big numbers, we just multiply them together. Same thing with division. If I have 4 over 12, I can put that together, and then the v to the fourth divided by v to the second is v to the 4 minus 2. So 4 over 12, I'm just going to reduce it. Again, mathematicians like fractions. V to the 4 minus 2 is v squared. So we just kind of rewrite that as v squared over 3. Because 1 times v to the second is v to the second. Last thing we got to do, power rule. When raising an exponent to a power, we multiply. The reason we're multiplying is because this exponent means I have 9 to the second 3 times. So 9 to the second times 9 to the second times 9 to the second. So that just goes back to the multiplication rule. We would add these together. 2 plus 2 plus 2 is 9 to the sixth. But mathematicians are too lazy to do that, so we just say it's 9 to the 2 times 3. 9 to the 6th. Again, c to the third 3 times. So c to the third times c to the third times c to the third. Nobody wants to do that. We just want to say c to the 3 times 3 is c to the 9th. You still get the same answer, we're just lazy, so we do it the fast way. Just like the division, just like the multiplication, if you have a coefficient, you gotta separate that out, so that's 2 to the 4th. Now b to the second to the 4th is b to the 2 times 4. So 2 to the second, 2 times 2 times 2 times 2 is 16. And 2 times 4 is 8, so just 16b to the 8th.